If you look at the tech ecosystem of 2026, it looks like a single, meticulously designed network. Phones, computers, and cloud servers are seamlessly integrated into a cohesive unit. To a casual observer, it looks exactly like a master plan executed by corporate visionaries. But this ecosystem wasn't the original goal. It's the result of trillion-dollar corporations hitting massive brick walls in the early 2020s. They didn't build this because they wanted to. They built it because their first attempts failed. Apple burned roughly $10 billion on Project Titan, a self-driving car that would never reach consumers. This early sensor array shows the physical burden of that project, a decade of research into machine vision that ultimately went nowhere. Other giants hit similar dead ends. Microsoft was forced to cancel its resource-heavy Windows subsystem for Android after it failed to gain traction, and the first advanced AI models were severely bottlenecked by daily usage limits that restricted professional use. The breakthroughs defining 2026 didn't arrive through a smooth progression. They exist because these companies had to recycle the wreckage of their biggest failures to find a new path forward. In 2014, the goal of Apple's car project required a processor capable of real-time machine vision and AI decision-making. At the time, that hardware simply didn't exist in a mobile form factor. Apple's Silicon team began designing a dedicated AI chip specifically for the car's sensors. They quickly realized this technology could be applied to consumer devices. By 2017, the first generation of this salvaged architecture debuted inside the A11 Bionic chip. This chart shows the growth of what we now call the neural engine. It launched with the capacity for 600 billion operations per second. In the years since, the capacity has scaled exponentially, reaching over 35 trillion operations per second in the M7 Ultra. Comparing this to a standard GPU highlights why this shift mattered. While a GPU uses a parallel grid for general graphics, the neural engine uses specialized pathways, optimized for low-power, high-speed machine learning tasks like image recognition and language processing. Apple spent $10 billion to learn how to implement large-scale AI. Without the pressure of that failed car project forcing them to invent their own silicon, the on-device AI ecosystem they have today likely wouldn't exist. Microsoft's first attempt to merge mobile and desktop was the Windows subsystem for Android. It was a closed system, restricted to the Amazon App Store, and it struggled to find a user base. The technical flaw was in the architecture. Local virtualization required at least 8 gigabytes of RAM just to run basic mobile apps, meaning mid-range laptops often lagged or crashed under the strain. To fix this, Microsoft pivoted to cloud-based app streaming. As this diagram shows, the heavy lifting now happens on Azure servers, streaming only the video feed to the user's laptop. This removed the hardware barrier entirely. This shift opened the door to the $116 billion mobile gaming market. Massive titles like PUBG Mobile can now run smoothly on a desktop setup without the user needing to install anything locally. Moving to a cloud-based architecture finally solved the problem of cross-save functionality. By abandoning local emulation, Microsoft successfully erased the boundary between the mobile phone and the personal computer. Even in the world of AI, early progress was restricted. OpenAI initially placed a 5-hour daily usage limit on its GPT 5.6 Sol model, creating a significant bottleneck for professionals who relied on the model for complex research. Intense competition from Google and Anthropic forced a change in strategy. To maintain its market share, OpenAI massively expanded its data centers with thousands of new servers, finally allowing them to lift the usage caps. Lifting those caps was a major technical hurdle because of how Sol operates. It uses chain-of-thought reasoning, where it transparently shows its thinking steps, and handles a massive 200,000 token context window. Both features demand significant real-time computing power. While market pressure shifted AI, legal pressure was shifting gaming. A landmark case in Brazil saw a user sue after his Xbox account, containing 150 digital games, was hacked and Microsoft refused to restore it. Microsoft argued they only sold a license to play, but the court disagreed. The judge ordered a full refund for the games and awarded moral damages, legally recognizing that a digital library has the same standing as physical property. This ruling, combined with the shifts in the AI market, shows that the control of corporate walled gardens is being challenged. User demand and legal precedents are forcing these companies to redefine how they manage access and ownership. This new flexibility has even reached the retro market. As technical barriers fall, 1990s classics are finding a new audience, helping the nostalgia market grow to $12 billion this year. But perhaps the best example of the unpredictable nature of tech is the story of a home crypto miner. Using a tiny $150 device called a BitAxe, they successfully mined a Bitcoin block and won a $200,000 reward. To understand the luck involved, look at the competition. The network is run by massive, industrialized operations with thousands of high-end devices. The odds of a single consumer device finding a block are roughly 1 in 18,000 years. The home miner's stroke of luck and Apple's hardware shift from a failed car project share a common thread. They both demonstrate that progress isn't a straight line. It's often the result of adapting to the unexpected. The tech landscape of 2026 isn't the result of a single clean roadmap. It's a network built on salvaged experiments, legal pushback, and the occasionally absurd stroke of luck, showing that true innovation is often a messy, unpredictable process.